So I
want to see the decibels to see.
will get different wires there.
Yeah. Mine's like 0.2. And then both of our B's are less than 1.
So sorry, we're supposed to discuss what's different.
Yeah, see if there's different, if you use different points, if you have the same answers.
So I think we use different y-intercepts.
I didn't teach your advice. I wanted to teach you.
Oh, okay. Then I might change it a little bit.
Yeah, so I use 0, 4, and like that to here is when we started systems of equations.
Okay.
Did you have some what were your systems?
I guess some systems.
Oh, you did 3.
This point I ended up ignoring because I realized like I wasn't going to use the y-intercept because it didn't look like it was 4 to me and I was uncomfortable using it. So I was going to pick 3 other points, but then I realized that when I picked points that were really far along the x-axis, like at 9, like even though it really looks nice at like 9, 6, when you plug in 9, you get 81. When you plug in 9 for x, x squared is 81. And I was like, I don't really want to deal with 81. Those numbers seem too big. So then I went back to the y-intercept. I did it as 3.5. Yeah. And I was afraid that if I used where the chain was sitting now for other points, but not for the y-intercept.
Okay, so what we're gonna do now is you're gonna use a graphing calculator to actually graph the equation that you just created and see how similar it actually is to the one that's on the report. Do you remember how to type it in and everything? Yeah. Do you got it?
Yeah. That's cool.
Mine doesn't look that, like the chain looks like it's almost coming down to the x-axis, but mine doesn't look like it's that close. Like, I don't know, like that chain clearly goes below 1,
Right.
but this one looks like it's very touching. But
Did
it's,
you type it in, right? And you guys have the same points, right?
well, this is where we get the points. I think I did type mine particularly.
Okay, so maybe because you used,
Because they can be different.
because his came up under probably because since it was estimating that,
Yeah.
it's gonna be a little bit different.
But did yours look really close?
I think so. That was actually. Yeah.
So yours doesn't quite touch, but yours looks close.
Then what's the 36? 6-1.
Yeah.
6-1.
Yeah, I think his is closer, even though I thought I was being smart and estimating the wires.
Well, to me, it looks like it's almost right at 4. I guess it looks, depends on like what angle you
Maybe
look
she's
at
doing
it.
it.
Yeah.
Okay, so. Okay, so we both compared and did that. So you guys kind of saw that if you would have gotten the same answers if you would have used the same y-intercept. So since it's a little bit off, it is gonna make your estimation, or not your estimations, your decimals slightly different, which you see did affect the graph slightly. If we had time, what I would have you guys do is I would move one of these sides over and see what what constant it might affect. So seeing if you expand the quadratic and the parabola, you might be able to see which constant it would affect and how it would affect it.
Wouldn't it affect all of them or just some?
I can't remember. I haven't done this in a while. But you would see how it would affect the thing. And I would have that for groups that have gotten done faster than other ones. So we're gonna go ahead and move on to the summary. Okay, so first we're gonna talk about more basic things. So we kind of already discussed several things outside and like in our world that you have these parabolas. We said building structures. Evan, what did you say? I can't remember.
Like the bridge.
Oh yeah, the
The
Golden
top
Gate Bridge. That was an example. Or like under the bridge, there's some. Andrew, can you think of any more that we haven't said?
When we first started talking about parabolas, we talked about throwing things up in the air.
Okay,
And
so
like the path that they travel.
right, so it would be more of an upside down one though, right?
Yeah.
So the opposite of what we have right now. Okay, anything else? Dad?
Drive through it out. Tunnel and street.
Really?
Yeah. It's almost like in the.
So was it like you drove through it or was it?
Yeah, like the tunnel went through. They just drove through the mountain. It was crazy.
Okay, so that's a good example that you've actually really seen. Okay, so in the equation of the parabola, y equals x squared plus bx plus c, why do you guys think that a, b, and c are constants? Whereas x and y are variables. Maybe start with x and y. Why do you think that those are variables?
Well, that's what the X and Y is where we plug points for a specific graph.
Okay,
Like what was plugging in variables? You know,
so the
plug
variable is
in
always
variables.
changing.
Yeah. A, B, and C, they seem maybe not constant, but they were like unknown.
Okay,
Yeah, they
Whereas
would.
X and Y, they weren't unknown, like we could make them whatever.
okay, but once we've solved for a, b, and c, and we plugged them into the calculator, we could see that a, b, and c would stay the same, and x and y, you would keep plugging those in to get a different coordinate for y. So you can kind of see how x is changing.
Right.
So you're gonna use a new x, and since a, b, and c are staying the same, you're gonna have more of a relevant y to plot the parabola. Okay?
Yeah. Was it like in science class where we have independent variables?
Yeah, it's pretty close. Like if we would make a actual graph, we would have an input, like our x would be our input for the formula, and then we would have the output. So it would be,
Should be our y.
yeah, which would be our y. Anything else to add? So if a graph has an equation of the form y equals mx cubed plus kx, and the point is 8,5 is on the graph, show how you would substitute the coordinate into the equation. So what I'm gonna have you guys do is I'm gonna have you guys, someone come up to the board, and the class is gonna help him write it out. So does anyone wanna volunteer?
Sorry. So I have y equals take mx cubed plus kx.
We have the point 8,5.
So one of these I know is my x and one of these is my y. This one is my x. So I'm just gonna put 5 equals m8 cubed plus k 8.
Alright, Evan, are you agreeing so far?
I do agree.
Alright.
So 8 times 8 is 64. 64 times 8 is 12.
Okay, so without anything else, can we go on any further?
Well, I think we need another plan so that we could use a system
Right.
to find that.
So,
Like I could guess that, I don't know, to me what I noticed is that one of these is gonna have to be negative.
okay.
Because if this is positive and this is positive, then like 500 calls a lot bigger than 5. So
Is that, it's that algorithm in discrete?
What's to solve?
you mean one more in addition to 0, 0? Or
No,
one
one
more in
more.
addition to 8?
Because do you think that 0, 0 will give you any hope? Okay, so since 0, 0 wouldn't be very helpful, let's like not think about that point. So think about having only 8,5 right now. How many more additional to that do you think we would need to solve for n and k?
I think we'll need one.
Okay.
I would just plug in 1 because that's consistent.
Okay.
X equals 1. So I have y equals m plus k. And
So do you wanna show up on the board?
So that if I have y equals m plus k, like as long as I know what this y is, then this seems like it'd be an easy one that can help me make a system.
Okay, so you think we would only need one more additional point, right? Okay, good. So the last question is, let's discuss what it means to say that x and y are variables, but n and k are constants.